right, so this video is going to look at the area of a trapezoid. And so I want to start out by thinking about where this actually comes from. So we know that there is not necessarily going to be good symmetry in every trapezoid, but if we take two trapezoids, we actually are going to have great symmetry if we do a little bit of moving. Now, in Notability, when I move this, it's going to change sizes a little bit. I'm going to do my best to keep it the same size. But envision going ahead and rotating that shape. Notice how it will fit, like I said, if I could keep it rigid so that it wouldn't change sizes. Notice how it fits perfectly to make a parallelogram. So when we are thinking about specifically the area of a trapezoid, it really comes from the area of a parallelogram. So I'm going to go ahead and label this as base 1. And then I'm going to label the longer base as base 2. Doesn't necessarily matter which is which. I just want to be consistent. So here's base 1, here's base 2. Now, if I wanted to find the area of this entire parallelogram, I would take the area of this entire base, right? So my area of my parallelogram would be my entire base times my height, and my height would be the altitude or the perpendicular height drawn in here. Now, what is the area of this base really, this parallelogram? It's the area of what I've labeled base 1 plus base 2. Right? It's not just one of these, it's this one and this one. Total is the base of my parallelogram. So I would have base 1 plus base 2 times the height, and that would give me the area of my parallelogram. But I don't really want the area of a parallelogram. I want the area of a trapezoid. Well, if I look at this, if I know the area of the parallelogram, if I split it into two equal parts, then we get the area of the trapezoid. So we're just going to divide it by 2. So our formula for the area of a trapezoid is going to be base 1, which notice is the one of our two parallel sides, plus base 2, which is the other of our two parallel sides, times the height, which is right here, all divided by 2. Okay? So let's take a look at how we can use this. So when I'm using this, the first thing I'm going to do is I'm actually just going to copy and paste this formula right here for us to reference. When I look at this, I can fill in some of this information already. Base 1 can be 14 because that's one of my parallel sides. And 20 can be my base 2 because it's another one of my parallel sides. And then I don't really know what my height is yet, so I need to figure that out. So let's go ahead and draw in my height. So here's my height. I don't know what it is, but I do have a right triangle here, and I know one side and I know one angle, so I can find that height using some right triangle trig. So I'm going to set that up. This is opposite. This is hypotenuse. So we're talking about sine of 72 degrees is equal to the opposite side, which is my height, over my hypotenuse side, which is 13. And I could cross multiply. And now I know exactly what my height is. Now, just like before, I don't really want to type this into my calculator because I'm going to like get a rounded answer and it's going to lose some of my precision. If I do want to get a rounded answer, make sure you keep at least 3 decimal places until you're totally at the end of the problem. But what I'm actually going to do is I'm actually going to put in for my height, I'm going to put this whole thing right here. And that way I'm not going to lose any accuracy here when I'm entering this into my calculator. So I'm going to enter it just like it looks, 14 plus 20 in parentheses times 13 sine of 72. And that gives me 420.3669, but I'm not done yet. I haven't divided by 2, so I'm going to divide by 2. And that gives me 210, and this says round to the nearest tenth, so 210.2. And because this is area, I have centimeters squared. So if you want to know what this looks like, I will go ahead and take a picture for you on my calculator of how I did it. Here's what it looks like for me. I just went ahead and typed it in exactly as we saw it. Right? You can ignore this. This is from old stuff, but 14 plus 20 times 13 sine of 72, and then I divided it by 2. And there's actually a little bit of an error on this problem, so I just went ahead and fixed it. So let's take a look at an example where you have to kind of put it all together. So when I take a look at this one, I am going to break this into 2 parts. So first I'm going to consider this rectangle, and I'm going to find the area of that. And we know the area of a rectangle is base times height, which is 26 is the base, 10.5 is the height. So my area of my rectangle is going to be 273. Now, I also need to find the area of this trapezoid, and if this base here is 26, so is this one here because of the rectangle. So when I start to try to find the area of my trapezoid, I can at least figure out the sum of my base 1 and base 2. I can see my base 1 is 18 and my base 2 is 26. The problem is I still don't know that height yet. So I'm going to go ahead and draw in my height right here. And if we think back all the way to some of our previous units, we've kind of thought about this before. And if I drop 2 altitudes, I've created another rectangle. So this distance has to be 18, which leaves a total of 8 to be split between this part and this part. Now, we don't always know that those parts are going to be the same, but because this is an isosceles trapezoid, we do know that those 2 legs are the same. So if I take my 8 that's left and I split it evenly into 2 parts, I have 4 and 4. Now, the nice thing is I see that I actually have a 3, 4, 5 triangle here. So I now know my height is 3. So when I go ahead and calculate out, I get 66 for my area of my trapezoid. And I have 273 for my area of my rectangle. And so my area of the entire shape is going to be my rectangle plus my trapezoid, which total gives me 339. And this was in meters, but area is meters squared. All right, now one last example we're going to take a look at. This one isn't drawn for us. It says we have a trapezoid, so I'm going to go ahead and draw it. It says that it has the area of 44 meters squared. We know the altitude measures 4 meters, so that makes this height 4. And one base measures 15. So I don't know which base it is. I'm just going to label it in one of the spots. It doesn't really matter. And I want to know what is the length of the other base. So when I think about my area of my trapezoid, I have my one base plus my other base times my height over 2. I know my area is 44. I know one of my bases is 15, but I don't know the other base. The altitude is my height, so I am left with an equation that has just one unknown variable, and I can solve for that. So there's a few ways I could do that. I'm going to go ahead and multiply both sides by 2 so that I can get rid of that. So I get 88 equals 15 plus the other base times 4. I'm going to divide both sides by 4 to get rid of it. So I have 15 plus my other base equals 22. And I'm going to subtract 15 to get rid of that. And so I find that my other base is 7. And I'm going to go look and see what is my unit of measure. Looks like meters. So I was able to figure out that missing information. All right, good luck with trapezoids.